Hi guys, it's Mr. Pollen. Today we're going to be talking about acceleration and how it relates to Newton's second law. Acceleration is the rate at which speed increases. Traveling on a hill either at an incline or at a decline will affect your acceleration. If you travel uphill, you're going to have a decline in acceleration. If you travel downhill, you should have an increase in acceleration. Units of acceleration. To calculate acceleration, you divide the change in speed by the amount of time it takes for the change to happen. Alright? So you're going to have your change in speed, you're going to have your final speed subtracted by your initial speed divided by the time it takes for that change to happen. Okay? And that will give you acceleration. We'll look at more of these formulas on the next slide. Metric units. If the change in speed is in meters per second and the time is in seconds, then your units for acceleration is meters per second, okay? And when we write that out, we're going to do a shorthand version of that, and it's going to say acceleration is going to be written as meters per second squared instead of writing meters per second. Calculating acceleration. To calculate acceleration, first you have to find the change in speed by subtracting your starting speed from your final speed. Then you divide the change in speed by the time over which the speed changed. So the amount of time from your initial velocity to your final velocity, the amount of time it took between those, that's what time is going to be represented by. Colby glances at the speedometer on his bicycle as he rolls downhill. It indicates he is traveling at 14 meters per second when he initially looks at it, and 20 meters per second 4 seconds later. His acceleration is what? The first thing we have to do is we have to put down our formula. So that's going to equal acceleration equals final velocity minus initial velocity over time. So let's talk about our variables here. 14 meters per second is our initial time, so that's V1. All right, and 20 meters per second is our final time, so that's V2. So we're going to plug those in. Okay, so 20 meters per second minus 14 meters per second over. Now we need to figure out what our time is. From 14 to 20 seconds, how much time passed between that? That would be 4 seconds. So that 4 right there is your time. That's going to go underneath 4 seconds. Now I'm going to subtract that 20 from that 14. When I do that, I get 6 meters per second over 4. When I divide those, that gives me 1.5 meters per second squared. Okay, positive and negative acceleration. Right? If you have positive acceleration, objects speed up. If you have negative acceleration, objects slow down. I hope that helped you understand acceleration. If you didn't understand something, please go back and rewatch it.